Imagine a star so large that if you placed it where our sun is, its surface would stretch beyond the orbit of Jupiter. These are the biggest stars in the universe, and they are almost impossible to truly comprehend. When astronomers talk about the biggest stars, they usually mean size, not weight. Some stars are heavy but compact, while others expand into enormous diffuse giants. The largest belong to a rare class called red hypergiants. These are aging stars near the end of their lives, with outer layers that have expanded into vast, unstable atmospheres. One of the largest known stars is UY Scuti. It is located about 9,500 light-years away and has a radius roughly 1,700 times larger than the Sun. If UY Scuti replaced our Sun, it would swallow Mercury, Venus, Earth, and Mars, and extend close to Jupiter's orbit. Despite its size, it is incredibly low in density. Its outer layers are so spread out that it behaves more like a thin cloud than a solid sphere. An even larger candidate is Stephenson 218. This red supergiant may reach up to 2,100 times the Sun's radius. At that scale, its surface would stretch beyond the orbit of Saturn. However, measuring stars this large is difficult because their edges are not clearly defined and are often hidden behind thick clouds of dust. Another extreme example is VY Canis Majoris. This star is highly unstable and constantly ejects massive amounts of gas into space, forming a chaotic surrounding nebula. Its size is estimated between 1,800 and 1,500 times the Sun's radius. Instead of appearing as a smooth sphere, it looks more like a star in the process of breaking apart. Not all giant stars are distant or hidden. Betelgeuse, visible in the constellation Orion, is a red supergiant about 700 to 1,000 times the Sun's radius. In 2019, it dimmed unexpectedly, leading scientists to consider whether it was about to explode. It didn't, but the event showed how dynamic and unpredictable these stars can be. Stars grow to these enormous sizes during the final stages of their evolution. As they run out of nuclear fuel, their cores contract while their outer layers expand dramatically. This creates a delicate balance between gravity pulling inward and radiation pushing outward, causing the star to swell to immense proportions. Eventually, that balance collapses. These stars end their lives in powerful supernova explosions, releasing vast amounts of energy and scattering heavy elements like iron and gold into space. What remains can become a neutron star or even a black hole. The biggest stars in the universe are not just massive. They are temporary giants, living fast and ending in some of the most violent events in existence. And somewhere out there, there may be even larger stars waiting to be discovered.